So in this video I'm going to be going through the wall running, vertical wall running, ledge grab and mantle functionalities. So, um, so if I come into my third person blueprint, in fact if I go back into my content browser, you can see I've got a blueprint class which is an actor component, and I've created that and that's called Parkour movement, which is where we're going to be doing most of the stuff. That's the Parkour blueprint. And if I come into third person character blueprint, we're accessing that Parkour movement blueprint and we're initializing that. So we're calling the initialize function from the Parkour movement blueprint. And we're doing that from the event begin play. So when we do the begin play in third person character blueprint, we're going to do this section. We're doing some of the stuff from that Parkour movement blueprint. So there's one here. So in the jump, if you do the jump action, then after doing the normal jump action, we're also going to go through the jump event in Parkour movement. So that's going to happen if you are already doing a Parkour movement and we do a jump event, which is most likely going to be jumping off the wall when we are running on the wall, or when we've got the ledge grab and we want to jump off. We're also doing stuff like event on landed, which is similar to on jump, and we're also doing event on movement changed, and that's how we're figuring out which movement mode we're in currently. And we've got this movement change function inside the Parkour movement blueprint, so we'll take a look at all that stuff in a moment. So if I go into the event graph of the Parkour blueprint, so this is the initialize function, which is what we are calling when we first start the game. And in the third person character blueprint, we have this initialize connected to the event on begin play. So the first thing we're doing is we're taking in a character. So we're taking self as the character as the input to the initialize function, and we're then taking that character and we're setting that to a local character variable down here, and we're also extracting the character movement from that and setting that to a local variable. We're also taking the gravity scale from the character movement, we're setting that to a variable called default gravity. That's how we're going to reset our gravity every time we change it. And then we are calling certain functions with a timer set, and this is going to happen really fast, so it's going to be 0.0167 seconds. So that's how many times we're going to run call this wall run update event. And this wall run update event is going to run 4 things in sequence. So we're first going to do the wall run, and we're going to do the vertical wall run, mantle, and then character take function. So these are obviously collapsed nodes, and there's more stuff happening inside it. So before we take a look at those, I'm going to take a look at what other stuff we have in the event graph. So we have the land event custom event, we have the jump event custom event, and all these red are custom events. Most of them, yeah, I think all of them down here are custom events. So movement changed, Parkour movement changed, and this is how we're figuring out which movement mode we're currently in. So this is going to take a look at the default movement modes that Unreal has, like walking, running, swimming, and we're not really going to go past walking and sorry, don't really have a running mode. We just have running comes in walking. So the 2 main modes we're going to take a look at are walking and falling. So falling is when we are in the air and we're getting pulled back down by the gravity. We're not going to bother with other modes at the moment, but we'll take a look at those later when we get into sprinting and all that stuff. Parkour movement mode is our own custom mode, and it's associated with the Parkour move enum that we've created, which we'll take a look at later. And we also have a custom event for camera shake. So when we're going to play a camera shake, we're going to take certain things to do the camera shake, and we're going to do the right one. Also, this event take is basically doing some debug stuff. It's not important to the whole thing. We can just take it out and nothing would change, because this is just debugging some particular value for some reason, which we'll eventually take out at some point. So, wall running node. It's got a gate, and the gate has 2 events, custom events called open wall run and close wall run. So depending on whichever event we call, we're going to open or close the gate, and that's a simple gate. And if it's open, then we're going to also run this function wall run update, and this is where most of the stuff is happening. So so in the wall run update, we're going to first check that we're going to use this can wall run macro to check if we can wall run. And if I come in here, what's happening here is we're looking at the current Paco movement mode, and if that's none, or if we are currently wall running, so if we aren't wall running or we are currently wall running, then we're allowed to. So if you're doing some other Paco movement mode, then obviously we can't just wall run. So if we are not wall running, so if the current Paco movement mode is none, and we are already wall running, then we can come in here, and this is gonna, whether either of these are true, and this is true as well. So if the forward input is greater than 0, so if we are moving forward, so if you're not pressing the forward input, that means we can't wall run. So if either of those, if both of those conditions satisfy, then we're gonna set the output to true. If I go back, so we're gonna branch out using that boolean. And if that boolean is false, so if you can't wall run, then we're going to call the wall run end function. If you take a look at this, basically what this is doing is it's checking if you are wall running, then it's going to branch out and set the Paco movement mode to none. And based on whether we have changed anything, because the set Paco movement mode is a function which obviously checks if it has changed anything, and that's going to basically depend on whether the movement mode we have passed in here is same as the current movement mode, then it won't change anything because it's already the same. Otherwise, if it's different, then it's going to change it, and if it is changed, then we're going to branch out from here, and we're going to close the wall run gate, and then we're going to set a timer by function name to reopen the wall run gate in a given time. So reset time is going to decide how long it would take for us to reopen the wall run gate. So if I go back, so if we can wall run, so this was if we couldn't wall run, then we would end the wall run. If we can in fact wall run, then we're going to go here and we're going to call the wall run movement function, and that's going to take in a start and end, and that's eventually going to get plugged into a line trace. And the start is basically getting the actor location, and the end is using this macro called wall run end vectors, which we'll take a look at in just a minute. But before we do that, we're going to take a look at this wall run movement and where these values are getting plugged in. So if I come in here, wall run movement, so basically those start and end are getting plugged into this line trace by channel, and that's where this this is the starting position of our line trace and the end position of our line trace. And so now let's take a look at what those positions are going to be. So for that, we're going to take a look at the wall run end vectors macro, and basically what this is doing is for the start is going to, or end vectors, so the wall run end vector has got two outputs, right or left. And if we go back to the Paco movement update, sorry, wall run movement update, then we can see where we're actually plugging in this macro. We're in this area, we're just passing in the right value for the end, and if that's not true, then down here we'll go through this code again. But if that's not true, if we're not really doing the right wall running, then we're also going to check for the left, and that's where we're passing in the left. So that's why in this macro we have two outputs, and we're going to plug either of those in different situations. If the right's not, if the right doesn't happen to be the case, then we're going to check for the left, and if neither of those are the case, then we're not wall running. So let's take a look at the macro itself. So we're getting the character component from here, and we're accessing the get actor location from that character component, and we're plugging in the actor location in this addition of vectors. So the second vector that gets added into the actor location is we're taking in the right vector of the character, and we're taking in the line trace variable, which is just a number 75. This is the new magnitude we are giving to the right vector. So when we get the actor right vector, it's going to be a unit vector, and we want to give it a magnitude of 75. So we're multiplying that with 75 to give it a magnitude, and that's all that variable is doing. It doesn't have to be a variable, we could just set it to 75. And get actor forward vector is we're also taking the actor's forward vector and we're multiplying it by -35, so it's going to project that vector backwards with a magnitude of 35. So we can take a look at that here. So this is what's happening. This is circle is our character, this orange line is the right vector, and this blue line is the -35 forward vector projected backwards. And this is going to be our resultant vector because when we add three vectors together, so if we take a look, so we're taking the actor location, so wherever our actor is, this is our actor's location, and in that actor's location we're adding the right vector with the 75 magnitude, and the forward vector with a -35 magnitude, which is a backwards vector from the character's position, or whichever the direction the actor is looking in. So that's gonna project a line slightly backwards to the right. And if that line coincides, if the actor is right next to a wall and that line coincides with a wall, then the actor can basically wall run because that's coinciding with the wall. And if we satisfy other conditions, as we'll take a look at in a moment, then we would be allowed to wall run. So we're doing basically the same thing for the left as well. The only thing that's different is we're taking the 75 and we're timesing that by -1. So it's going to be -75, so it's going to be the left direction. By the way, I believe this is left direction. Oops. Okay, so going back, and we go into wall run movement, and so we're doing a line trace, and if we do hit something, then we're branching out, and if that's false, then we're just going to return this boolean on wall as false, and if we do hit something, then first of all we're doing some stuff here. So we're using this is wall run valid macro to see if the wall run is valid, and we take a look at that. So all we're doing is we're taking the wall run normal, so the wall that we are coinciding with, the normal of that, so at the point of contact, the normal of that from that wall, and if the z value of that is in this range, -52 and 52, so this is basically going to decide if the wall is slanted enough to be classed as a wall runnable wall. So then we can say the wall is valid, is a valid wall vector, and we're going to return a value for that, so true if it's valid or not, and we're also going to just return the vector as well. So we're going to see if the wall is valid and if we are falling. So we have to be in the air and being pulled by the gravity to be able to, get on the wall. We can't just run up to the wall and start wall running without pressing the space. So if both of those conditions satisfy, then we're just going to take the vector that comes out of here, and we're going to set that to the wall run normal, and basically the wall run normal is obviously what we plugged into here, so we could just directly pass in here as well, but we're only doing it if it's valid, or it doesn't matter. So so when we branch out from here, if it's true, then we're going to get into this branch, and that branch is connected to this thing, and if that's false again, we're going to return on wall as false. Otherwise we're going to carry on. So once we set the wall run normal to whatever value that's passed in, then we're going to launch the character. And to launch the character, what we're doing is its launch velocity is going to be so we're taking the wall run normal, and we're finding the cross product of wall run normal with the z-axis. So we've got the unit z-axis, so 1 on the unit, and this is wall run normal is obviously going to be unit vector as well. So we're taking both of those unit vectors, and we're finding it's the cross product. So wall run normal is going to be pointing towards you as a player, and the z-axis is going to be pointing upwards, so the cross product is going to be the direction that's perpendicular to both of those directions, which is going to be to the right or the left. I believe it's going to be the right, but we're just going to decide the direction. We're going to choose the direction with this variable called wall run direction, and this variable is just going to be -1 or 1 to multiply it with this vector to give it a direction in right or left direction. And the wall run speed is obviously how much of a magnitude we want to then give to that vector in the right or left direction to push our character with that speed. So currently our speed is set to 400, which I've just changed. I'm just going to set it back to 400. And that's going to be our launch speed. and we're overriding XY. And whether we override Z is going to be dependent on whether wall run gravity is set to true. So if it is set to true, then we are going to um, not override Z. So the gravity is still going to affect us. And if it is not set to true, if we've disabled wall run gravity, then we are not going to override Z. So that means we're not going to be affected by the gravity. And finally, if all goes through, then we're just going to return on wall boolean as true. So that's wall run movement. So if we come back to wall run update, from this wall run movement we're branching out, and if it's true, then we're going to set Parker movement to left wall. Well, this is what I'm talking about. So up here we're checking for the right one, and we're branching out. So if it's right, then we're going to go into right, and if it's not right, then we're going to check whether we were on the right wall, because we could have just come out of right wall run, and if the current Parker movement mode is right wall, that means we were on the right. So now it's time to end the wall run, because we're no longer on the wall, but we were on the right, because that's the current Parker movement mode. But if that's false, so if you're not on the right, and that means we could still be on the left, which we haven't checked for yet. So if that's false, then we're going to come down here and check for the left with the same sort of situation. We're going to call the wall run movement here. And if that's true, then we're going to do the same thing as we do for the right, which is we branch out here, depending on if we are on the wall. And if it's false, then we're just going to wall run end, because now we don't need to check for any other directions, because we have already checked for the right and left. And if it is left, then we're just going to set the set Parker movement mode to left wall run, and then we're going to branch out based on whether we have changed it. And then we're going to come up here and set the gravity scale to this thing. So let's take a look at this thing. So we're taking the current gravity scale from the character movement, and we're providing it a target gravity to interpolate to. So the default, which is the target, is probably going to be the default, which is going to be 1 from in the beginning, and we're slowly interpolating to this target gravity, which is 0.25, and we're doing it with an interp speed of 10, and we're also providing the delta time. So it's going to interpolate the gravity from 1 to 0.25 in this case, and it's going to plug in that value to the gravity scale. So we're setting the gravity scale to 0.25 slowly. And that's our wall run update, and that's how we do the wall run update. So if we go back, so this is our wall run node, and if I go out, so that's what we're doing. So let's take a look at some of the stuff that we did for wall run, running, things like jump. So jump event has got more than just the wall running functions, but we're just going to take a look at the wall running function. So if you want to jump off the wall while you're doing the wall running, then you have this function called wall run jump. And basically what that's doing is it's first checking if we are wall running. Actually that's wall run end. No, it's not. Yeah, so if you have jumped off the wall, then if you are wall running and if you have jumped off the wall and we've called the wall run jump, then we're first going to end the wall run. So it's going to do whatever it does to end the wall run, closing the gates and everything. And once we've done that, once we've ended the wall run, so we've kind of reset most of the stuff regarding wall running, then we're going to launch the character. And to launch the character, we're going to, for the X, we're going to take the wall run normal, we're going to times that by a wall run jump speed. So opposite, so it's going to be 600, so it's going to be off the wall, so it's going to be in the direction of the wall run normal. So we're no longer sticking it to the wall, so it's not going to be in the opposite direction, but in the direction of the wall run normal. And we're going to launch it in both X and Y axes with the same wall run jump speed, because we're timesing them both by the same variable. And for the Z, we're plugging in a jump value, so that's going to be 400. And basically we're going to override the Z. So we're going to set the jump to 400. Okay, so it's going to be launched by Z. Okay. So if we go back, so that was our jump event for wall run, and the land event for wall run is going to be wall run end, and all that stuff is related to vertical wall run. But close gates is also obviously got close wall run gate as well. We'll take a look at that one once we cover vertical wall run as well. So Now if we take a look at how we're deciding which movement we're on. So movement changed is basically an event that we call in third person character, as we saw before down here. So on move, we've got a inbuilt on movement mode changed event, and we call when that is called, then we call our custom event from the Parker movement blueprint. And what that does is it checks if this character movement is still valid, then it's going to set these local variables, which are of the type obviously of expand that e movement mode, which is a inbuilt movement mode. So it's going to set those local variables to those whatever values passed in from here, and then we're going to go to open gates node, and what that's doing is checking if the previous mode is walking and the current mode is falling. So that means we can open those wall running gates, and if both of those are true, then we can open those wall running gates. So if we are eligible for if we are in the walking mode and we transitioned into falling mode, that means we are eligible for doing wall running stuff. And that's what we're doing for the movement changed. And for Parker movement changed, we are setting similar local variables, but in this case the local variables are of custom type that we've created, eParker movement mode, which is an enum that we created. And we can take a look at that enum. In fact, if we come here, we've got this enum, and basically this enum has these different values: none, left wall run, right wall run, vertical wall run, ledge grab, mantle, slide, sprint. So those are the enum that we select from when we're setting these values. And finally we do reset movement, and what that is doing is it's checking whether the previous movement mode was none. Then we're going to branch out. If that's true, if the previous movement mode is none, then we're going to set the gravity scale to default, and we're going to set the movement mode to depending on what our previous Parker movement mode was. So for none, left wall run, right wall run, vertical wall run, and ledge grab, for all of those Parker movement modes, we're going to set it to falling. Otherwise, if it's mantle, slide, or sprint, we're going to set it to walking, because they make for slightly better animation transitions. So that's how we reset the movement mode, the default movement mode. And this camera shake we'll talk about later, but basically we're branching out from here. We're taking as an input to the play camera shake, we're taking in a shake, and we're going to play that shake, and we're also checking this. So this is just a boolean which allows us to switch the camera shake on or off whether we want it or not in our gameplay. And we're branching out and we're just playing the world camera shake, and the epicenter is going to be the character's location obviously, and we've got the inner radius as 0, outer radius as 100, and we don't really mess with those values. And as I said, that's just debugging. So let's take a look at the vertical wall run. So I come up here. So this is the vertical wall run. So this is a gate which we open or close based on these events, and we also close the mantle gate if we close the vertical wall run gate, because they are kind of connected. You can only mantle once you're vertical wall running. So, and if the gate is open, then we run the vertical wall run update. So we take a look at that. So this is vertical wall run update, and similar to wall run, we check whether we can wall run, and that's dependent on whether we have a forward input and we're falling, and whether the previous Parker movement mode was either none or vertical wall run or wall running. So in this case we are allowed to transition from wall running to vertical wall run, but in the opposite case we can't really we could implement that in, but currently we don't have a functionality that allows us to transition from vertical wall run to wall running, but we can do it from wall running to vertical wall running. That's why that's like a condition that we could be in if we want to if we want to be eligible for vertical wall running. So if we can wall run, then we're going to do this stuff. If we can't, we're going to do vertical wall run end, which is going to be similar to ending the wall running. So we're checking if we are vertical wall running or mantling or ledge grabbing. If either of those are true, then we're going to go ahead and set the Parker movement mode to none. We're going to branch out. We're going to close the vertical wall run gate. We're also going to close the mantle check gate. That allows us to check for mantling. And we're also going to set a timer by function name to open vertical wall run gate. And that's going to be reset by depending on the timer reset time variable. So if we can in fact wall run, so if this is true, then we're going to do a capsule trace in this case. So the capsule trace is going to be from slightly above the player's eyes, then all the way to its feet, which is going to be slightly above its capsule end location. So let's take a look at the mental vectors for this. So we're taking the character, we're extracting its we're using the get actor eyes viewpoint to get the eye location of the character. We're taking its location, and we're adding 50 to that location. So we're taking the eye location, we're adding 50 on the z-axis. So we're slightly moving it, the point slightly 50 units upwards. And we plug that into this vector addition. So the second vector is for the eyes, which gets plugged into the eyes output. So the second vector for this is going to be we're taking the active forward vector, we're timesing that by 50. So forward vector is going to be a unit vector pointing forward. We're timesing that by 50, so we're moving that 50 units forward, and we're adding that to this. So from the eyes, so from 50 units above the eye, we're adding 50 units forward. So slightly above, 50 units above, and 50 units forward from the actor's eyes. And for the legs, for the feet, what we're doing is we're taking the character's capsule component, we're finding the capsule half height, and we're subtracting the mantle height from that capsule half height. So capsule half height is about, for this character, it's about 96, and we take away 40 from that, so we're left with about 56, which is what we're plugging into Z. And we're also taking the actor location, and we're subtracting from the Z component of the actor location this value that we got from here, so about 56, we're subtracting that away from the actor location. So we're going to be left somewhere around 40 units above the end value of the capsule, somewhere around those values. So then we just add that in to the actor's forward vector times 50. So again, we want it to be on the same vertical line as this eyes. So we're obviously adding that to the forward vector as well. So this decided our height, and this decided how forward from the character this is going to be. So we want it to be on the same line, same vertical line, the capsule that goes up and down. So we plug this in for feet. If I go back, so plugging in the eyes and feet for the start and end. So it's going to be a capsule going up and down from slightly above the character's eyes all the way to somewhere around its feet, which is 40 units above, around 40 units above its ending location. And if there is something in, if we hit something, if the capsule hits something, so capsule radius is 20 and half height is 10. So if the capsule has got some range in which it can hit something in front of the character, and if it does, then what we're going to do is we're going to branch out. And if it's false, then we're going to do vertical wall run movement. If we don't hit anything, then we're going to do vertical wall run movement. And if we do hit something, we're going to do other stuff, which we'll talk about in a minute. So let's talk about vertical wall run movement, which I think we might have gone through already. Oh no, we haven't. So vertical wall run movement is what allows us to do the wall running. So we're doing the line trace again, but this is going to be a straight line trace in front of the actor. For the start, we're just using the feet, so we're doing the line trace from the character's feet. It makes sense to do it from the feet rather than from the eyes, because the wall could be lower than the eyes of the character, so we want it from the feet. And for the end, we're just adding a value to the feet. So we're taking the actor's forward vector, we're timesing that by, depending on something, which we'll, since we're turning the character on the y-axis, we need to extend this. So this is just because we're going to be also rotating the character depending, but since it's going to be wall running, we don't want to just we don't want it to just wall run uh, in a perpendicular posture. So we want to turn the character as we were wall running. So that's why we have to extend this 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 line trace, because if you're wall running, the line trace is going to be from the feet, so it's gonna need to be longer. So that's why we're doing this, and so depending on whether we are doing vertical wall run. So if we are currently doing vertical wall run, then we want the line trace value to be 120. Otherwise, if we haven't yet started to do the vertical wall run, then we want it to be 50. So if we and then we times either of those value by the forward vector to give this line trace magnitude, and then we add that to our feet. So from our feet to whatever value we assign this forward vector to, we're going to do a line trace, and that's going to see if there's a wall in front of the character. And if we hit something, then so this is going to tell us whether we hit something. So that's going to be the Boolean return value. So if we hit something and the forward input is more than 1, so more than 0, then we're going to branch out from here, and we're also taking the out hit object to extract different information from. But first, let's take a look at if we don't hit anything, then we're going to do vertical wall run end to reset the wall run values, vertical wall run values, as well as the mantle check gate. And if we do hit something, if it's true, then we set this vertical wall run vector local variable, and we set that with impact normal. So that's the vertical wall run normal, obviously. And then we set the Parker movement mode to vertical wall run, and then we launch the character. And to launch the character, we do you take the vertical wall run normal, we times that by -600, so it's into the wall. So normal is pointing away from the wall, and we want it to be into the wall, so -600. And because we're overriding x, y, we're just basically sticking the character to the wall. And vertical wall run speed is how fast we're going up the wall, so that's going to depend on this variable here, which we've set to 300. So that's vertical wall run. So if I go back, so if we don't end up hitting this function, so if we do hit something for the mantling, so for the capsule trace, if we do hit something and if it's true, then we set mantle trace distance float. That's going to be the distance from where the mantling started all the way to where it hits something. That's going to let us see how tall the surface, the walkable surface is. And we're also breaking the hit point thing, and we're extracting different information from here. So then we're going to do different stuff. So we're also going to check. So here we're also going to check if the surface that we have hit, so we're passing in this hit value, and we're checking if the surface that we hit is walkable. So that we plug into this branch here, which we're going to go to next. And if that's false, then again we're going to do vertical wall run. We're going to carry on doing vertical wall run movement. Otherwise, we're going to set the mantle position, so where we're going to end up mantling. So when we mantle, we're going to end up somewhere on top of the walkable surface. So that's going to be a position. So if we set, if this is true, then we're going to set the mantle position to where we end up, and we then going to close the vertical wall run gate, so we don't want to continue wall running. And we didn't take a look at this, so what we're doing here with the impact point, so the mantle position is dependent, so we take the impact point and we add a z value to it, and the z value is going to be the character's capsule half height. So we just add the capsule half height, and so we're just moving it up by the value of capsule half height from the impact point. So that's going to be a mantle position, and we close the vertical wall run gate, and we then do the ledge grab node. So let's take a look at the ledge grab node. And what this is doing is we're setting the Parker movement mode to ledge grab, and then we're disabling movement, and we're also doing the stop movement immediately. And both of those are being extracted from the character movement, as well as we're setting the gravity scale to 0 because when we're ledge grabbing, we don't want the gravity to pull us back down, so we're just stuck in that one position. So that's why we're setting the gravity to 0, and we're then going to play the camera shake for ledge grab. And we also need to go through the camera shakes that we've set up at some point. And so once we're out of the ledge grab node, we're going to check if we can quick mantle. So that's going to depend on the size of the wall that the capsule has hit. So the size. So let's take a look at the quick mantle macro. So in the mantle trace distance, which is going to let us see how tall the wall is, if that is greater than the capsule half height, so if that means the wall is much lower, then we can quick mantle. Otherwise, so if that's true, then we're just going to do the open mantle check gate. So if we can quick mantle, if we're going to immediately open mantle check gate, so we can quick immediately mantle. Otherwise, if it's false, then we're going to do the mantling in a given amount of time. So at the moment, I've set it to 0.05 seconds, 0.5 seconds, sorry. So that's going to pause for a second before it's going to let us mantle. So if you go back, so what happens when the mantle gate is open? So if you go to the mantle node, so this is the mantle node, and it's a bit more complicated than our other nodes, because we have certain things like we have mantle start custom event, we have mantle check custom event, and then we have the 2 gates here instead of just 1 gate. So 1 gate is doing opening mantle check gate and closing mantle check gate, which will allow us to do mantle checking, and the other gate is only going to be open if the mantle check is open. So and this gate, we're using open mantle check gate and close mantle check gate to open and close this gate, and that's going to call mantle movement. So mantle check is this thing here, and mantle check is going to first check whether we can mantle, which is going to be if we are, if we've got a forward input and we are currently ledge grabbing, or quick mantle. So we can quick mantle. Then so if you're either ledge grabbing or we can just quick mantle, so we don't need to ledge grab, then and we have a forward input, then we could just we return true. And if that's true, then we can allow mantle checking, and that's going to call this mantle start event. And what that mantle start is doing is it's setting the Parker movement mode to mantle, and it's branching out, and it's playing the camera shake for the mantling. And obviously that shake is going to depend on whether we're quick mantling, then we're calling it a quick mantle shake, otherwise we're calling the mantle shake. And then we finally we're closing the mantle check gate. So we've checked, and we got here through the mantle check gate, and now we're closing the mantle check gate, and we're opening the mantle gate. And once the mantle gate is open, then we can call the mantle movement. So we take a look at the mantle movement function. What's happening here is we're setting the control rotation and the position on the character. So we're first setting the rotation, so we're getting the character's controller, and from that we're extracting its rotation, and we're getting the actor's location, and we're finding the look at rotation based on the mantle position that we previously calculated. So we want the character to look at the position the mantle is, what position that we found, and we take that look at rotation and we plug that into the target rotation that we want to go to. We want the character to rotate to, and then we take the current rotation, and then we interpolate the current rotation to this target rotation with an interp speed of 7, and then we we plug that into the new rotation for when we set the control rotation that we extracted from the controller. So that once we've set the rotation, then we are going to do the same thing for location. So we take the character's current location, and then for the target we just pass in the mantle position, delta time, and interp speed, so how quickly we move to that new location, how quickly we interpolate to that new location is going to depend on whether we're quick mantling or we're just mantling. So mantling is going to be slower, so mantle speed is going to be 10 and quick mantling speed is going to be 20. So whether we are quick mantling, then we're just going to plug in 10 or 20 into the inter speed, and then we just pass in that new location to set active location. And here what we're doing is we're branching out based on this boolean, which is if active location, if the distance from the mantle position and the active location is less than 8 units, so that means we're almost there, we're around that location of mantle position, then we just consider to be there if it's less than 8 units. Then we can say that we have successfully mantled, and then we can do vertical Volrun end, and we do the reset time to 0.5. So that's our mantling. So that's our 3 nodes done. So if you go back to our events graph, so that's our 3 nodes here done, and then we have a character tick. So what's happening here is we have the current Parker movement mode, and then we're switching between all the Parker movement modes, and based on which modes they are, we're selecting a particular camera tilt. So we're tilting the camera slightly for things like left Volrun, right Volrun, as well as slide, and the rest of them have a straight. We're not really tilting the camera at all. And for vertical Volrun, we're not really tilting the camera, but we're tilting the character in the y-axis. So this is a function I've created that allows us to choose between which axis we want to tilt the character in. So in this particular one, we've chosen y. So we want to turn the character on the y-axis with a value of 55. Whereas for things like for normal Volrun, so if it's not vertical Volrun, for normal Volrun, depending on whether it's right Volrun or left Volrun, we are tilting the character by 30 on X and minus 30 on X, depending on which left or right Volrun it is. And we could take a look at camera tilt. So basically what we're doing here is we're taking the controller from the character, we're getting the control rotation, and we're breaking the rotation to X, Y, and Z, and we've got our camera tilt. So this is our function basically, and we're taking the current rotation, and our target rotation is just going to be we're taking the current rotations Y and Z, because we've got multiple ones here, and then we pass in the roll. Sorry, in this we don't have multiple ones here, so we're just for camera tilt we're just concerned with the x-axis, so we're just passing in the roll as the x value, so that's the only value we're changing. The rest we're keeping the same. That's why we're just taking the same values and plugging it in, and we're using an inter speed of 10, and we just set that to the camera's rotation. And for the character tilt, we've got slightly two different ones. So this is character tilt X, and this is character tilt Y, which I still need to comment. So at some point we might need to set it up for Z as well. Can't really think of a situation where I need to, so I haven't done that yet. But so this character tilt is doing a sequence of 0 and 1, and it checks whether we have set the X and Y or X or Y, depending on what situation we're in. Then we're gonna run either of these 2 nodes, and those 2 nodes are basically the same. It's just gonna change X as for the tilt if we've chosen X, otherwise if we've chosen Y for the tilt, then it's gonna use Y to tilt the character. And in this case we're obviously rotating the character, not the camera. So in this case we're setting the actor rotation, whereas in the camera tilt we were doing set control rotation. So that's the difference. Okay, so go back to the event graph. So that's our character tick, and take a look at the jump event. Then we go into the jump event, then in addition to the Volrun jump we also have the ledge grab jump. So if you go there, so the ledge grab jump is checking whether we're ledge grabbing, vertical Volrunning, or mantling. If either of those conditions satisfy, then we are allowed to jump off the wall. And if that's true, then we're first going to do the vertical wall run end, and then we're going to launch the character off the wall. So I think we've already gone through this, maybe not. So we're just taking the vertical wall run normal, and we times that by the ledge grab jump off force, which is 300, and the ledge grab jump height, which is going to be 400, and we're obviously overriding the Z. So similar to the wall run jump off, but in this case we're ledge grabbing or vertical wall running or mantling to be able to do that. So that's about it. If you take a look at the land event, that's just, you know, doing a wall run end, vertical wall run end, and it's closing the gates. It's closing the wall run gate and closing the vertical wall run gate, and we don't touch the mantle gates because that's happening inside the vertical wall run stuff. So we don't externally touch the mantle gates, because that's happening slightly inside our other nodes. And what's happening here? Jump event. So we call it jump event if the previous current parkour movement mode is none, and whether if you're falling, then if you're not falling, basically, if you're not falling, then we open the gates and we play the camera shake of jump land. So what that means is, like, we basically did the jump event, so we jumped off the wall, and if we're no longer falling after that, so that means we've hit the ground, then what that means is we're back on the ground and we can open the gates back up to allow for wall running again. And we also want to play the camera shake for when we land on the ground. And we've discussed these other nodes, I guess. Play camera shake. This is getting called, I believe, in the third person somewhere. Sorry, no, we were actually calling this play camera shake, and whenever we're doing the mantling and ledge grabbing. So we're just calling this, and we're passing in the shake value. Alright, so I think that's about it. I could just demonstrate it quickly. So if I press play, then if I do vertical wall run, then we're just turning the character on the y-axis by 55, I believe. Yeah. And if we come up here, we get stuck for a few 0.5 seconds, and if I press the up arrow or the W again, then I'm allowed to mantle. So that's so I just mantle. I don't have any animations for mantling, so that's why it looks a bit weird. So if I just want to show that we can get stuck mantling. Okay. Why can't you just get stuck mantling, man? So that was him getting stuck mantling, and then we climbed onto the wall. I also want to show that we could transition from vertical wall run to just... Oh, actually we can't transition from vertical wall run to normal wall run because we don't have the functionality implemented, but we can transition from normal wall run. So if I could just get a normal wall run going. I don't know what's wrong with that. So that's a normal wall run. That's a normal wall run, and we could just transition to a vertical wall run from a normal wall run. I'm just so bad at this today. So this might not be the best gameplay experience, so we might need to play around with this and see what we could do, but we could just mid-air start wall running. And also one more thing to show is quick mantling, so I think this is a good height for quick mantling. So we just get teleported onto the top of the thing without very quick mantling. So I think that's about it for these functionalities, and I'll be covering more functionalities later. So that was a quick mantle, or maybe it was a mantle, but it just shows that we quickly get teleported onto the top of the surface here.